Oh, okay. I'm Nick K5EF from Cummington, Louisiana. And, the ham radio world in the late 1940s was a very cluttered one. If you tried to operate on 75 meters, I'm reciting this from observations from Wes, because I wasn't around then. But apparently, because there were so many AMers on, and they were all running big signals, because that was about the only way you could get heard, it was just a sea of heterodynes, just audio beats, and how anyone could communicate. He just didn't understand it, and said there's got to be a better way. Now, during the war, he had gotten interested in single-sideband communications just because he had read about it. Documentation that he had gotten while he was doing other work for the war effort. He worked for a company called Covert Dual Signal Corporation, which was in Chicago. And prior to the war, they built equipment for the railroads. But unfortunately, the railroad really didn't want it. And it was unfortunate for them that the war came along, because otherwise they would have gone out of business. But they started building all sorts of equipment for the military effort. And one of the things that they did was do some very preliminary investigations on single sideband. That's what got him really interested in the technology. But if you didn't have big power in the late 40s, you just couldn't get heard, and it was just a mess. So he saw that single sideband could be a way of making it much more efficient for communications with all the heterodynes. And not only that, it occupied half the bandwidth of an AM system. Now, and George will talk about this today, more of the history, but when General Electric published a single sideband Junior, which we're fortunate to have an example of, just recently created and on the air and everything, so we could see how it worked.
Broad.
It wasn't broad then. In comparison to AM, it sounded pretty narrow. But in any event, guys started building these little sets up and other designs, because General Electric wasn't the first one to write about single sideband. In fact, QST had a number of articles in the late 40s that dealt with the subject, and hams were experimenting with it, and so was Wes Schum. He had designed his own single sideband rig. It operated simply on 75 meters, but it was crystal controlled, and it used the same tank type crystals that we see in another example of a radio here to make a filter to get rid of one of the sidebands. But it was difficult to make. You had to hand select the crystals. There was a limited supply of them. It wasn't anything that the average ham could just slap together and make work. One thing that's difficult about the single sideband Junior, it's a one frequency setup. So if you set it up for good sideband suppression on its crystal frequency, if you wanted to move frequency, you'd have to make all these adjustments again. So Wes thought, there's got to be a way of making this a lot easier for the ham, so he could operate on all the different amateur bands, not just 75 meters. And of course, that is Mr. Single Sideband. We haven't seen his picture in a while, but that's Wes actually doing a stage photo on the first 100V that came off the assembly line in Central. That's jumping ahead, though. So he wanted to bring single sideband to the radio ham, not as a novelty, but as a true operating system, something that you could use all the time in lieu of AM. And that result turned out to be the groundbreaking Central Electronics 10A. And I think we're all pretty familiar with what it looks like. And I was fortunate enough, by accident, to bid on a box that was on eBay that nobody wanted. And it's because I don't think anybody knew what it was. And that turns out to be a very early prototype of the Central Electronics 10A. And it's a prototype because if you open the top and look at the way it's constructed, you'll see that some of the little coil assemblies are mounted on plates so they can be pulled in and out as Wes and his team of one engineer would optimize the design and make it to get to the point that he could finally package it as the 10A. But you can see the layout of the controls is virtually identical to the actual production 10A. But it involves so many firsts that we take kind of for granted now. It was self-contained, did AM, phase modulation, single sideband, and CW. It generated single sideband at 9 megahertz, fixed IF, and that way you could use a 5 megahertz VFO, and plus 9 plus 5 gives you 14, and that gets you on 20 meters. 9 minus 5 megahertz brings you down to 75, and that's pretty much the reason why you see 9 megahertz IFs, crystal filters, in rigs today, is because Wes came up with the idea of doing it at 9 megahertz, and it's stuck all these years. Voice-controlled operation. Not too many rigs had Vox, which is a common feature, well, since the 10A. The QT was designed to eliminate noise pickup from the speaker of your receiver from inadvertently keying the Vox. And to make it a system, he developed a demodulator, a device that would go on the receivers so you could actually receive single sideband. It doesn't do you any good to transmit it if nobody can detect it. So he built a way of detecting it. Now, all of these were through license from General Electric. He was able to get a license at no cost because he was interested in promoting single sideband, and they really weren't interested in getting into the amateur radio market. So they saw this as no competition, but they also saw it as a way to maybe enhance the idea of single sideband. And so they were able to strike a deal where Wes could build his product and not infringe on their patents, and it didn't cost him anything. And it sold like hotcakes. Once it was built and developed, they just couldn't keep up with the demand. He started in a garage outside of his house, and soon he had a network of 5 different garages, and they all served by a back alley. And he would have his kids that he'd get from DeVry, who are actually putting the kits together or assembling the radios, and they had little wagons that run up and down the back alley picking parts up from these 5 different warehouses that he had. He had rented all these garages from all of his neighbors. So it really became a cottage industry. And everybody around him got involved. They just didn't know it. And Wes Schum sold amateur radio operators on the concept of single sideband. There's nobody that promoted single sideband any stronger, harder, or more deliberately than Wes Schum. Now, in this photograph that you see here, Wes is to the left, and his chief engineer and the fellow responsible for most of the innovation in the 100V transmitter is to the right. That's Joe Batchelor. Joe developed the broadband coupler scheme, which is in the Central Electronics 600L that's sitting there on the table also. That had to be one strong table. or they had the balance point set just right with its stack of receiver and the 20A on the other side, because if you've lifted a 600L, in fact they had one here yesterday, it didn't go on anywhere. So, and Central Electronics took flight. They were making the 10A, which had plug-in coils, but then it lacked a few features that the hams started homebrewing in their 10A. So Wes said, well, let's just put them in a new improved model called the 10B, which had those few little operating conveniences. The 20A came out also in 1954. And one of his assembly crew said, well, why are you making another radio? I mean, the 10A is selling like crazy, and his comment was, don't confuse me with the facts. This thing is going to sell. People don't want to plug coils in and have to keep opening the lid to change the 2 coils. So they made the band switch 20A and gave it a little more power with 2 vinyl amplifier tubes. the broadband amplifier, the 600L, came out first in 1956. So if you look at the serial number on your, if you have a 600L, they all start with 56, and that was the first year that they were made. The 100V, that we could have a discussion on the 100V all by itself in terms of how it was developed and started, and the problems that they had in making it yield. And in fact, maybe we'll do that next time. But it was a revolutionary transmitter because it incorporated broadband tuning, which no vendor had before that, where you didn't have to dip the plate and adjust the loading on the transmitter or peak all the different low-level stages. It was all done by design. So all you did was adjust the VFO to the frequency, and that was it.
He invented the lazy hand.
Yeah, he did. Where all you had to do was move one wrist. Yeah, that was all. Yeah, if you met Wes and you hung around him long enough, you realize that he liked to conserve motion. He could sit in his chair for hours at a time without moving, except maybe to talk to you, but that was about it. He was just a wonderful guy. And the ultimate, of course, was the 200V, and it had a lot of different improvements on the 100V. Solid-state power supply, better mixer tubes to reduce some spurious emissions that were present on the 100V. The broadband couplers, as they continued to make these sets, continue to be refined, and the ones in the 200V are absolutely perfect. And much different than the earliest 100Vs. So it was a very good set, and it was easier to work on, and they're typically all these radios are very reliable. Some of this we've already talked about before. You know, we do have this prototype here that shows that he was working on the design of the 10A. The 10A was first advertised in September of 1952 in QST, but he was working on it quite a bit earlier. And this prototype, we can tell from the date codes on the electrolytic capacitor that the can and put in there about when it was built, you know, in the time frame. So it was a good year before, and we're pretty certain that he started work on packaging this 10A in about April or so in 1951. And if you read, go to the central website that I have, that's actually a video that has Wes telling in his own words a story about he and Art Collins buying a 10A kit, and they couldn't get it together because they just didn't read the instructions. Is that all of it? Oh, and there's also a story about, you know, AMers really despised single sideband back in the 50s. I mean, it was just hot and cold. Sparks would fly at these conventions. There were all kinds of guys that would howl and whistle and make cut up and do all this stuff in these presentations. But that didn't stop Wes. I mean, he had a rock-solid demonstration where he could switch between upper and lower sideband and show that there was no interference and there were no heterodynes, and it shut most of these guys up. But when he was at a Hamfest in Lithia Springs, Georgia, he was giving his presentation. These two big guys came up, and Wes was a little small guy. He got up to about this high on me. You know, these two big guys that were about 6'3", 6'4", and about 250 pounds, grabbed him under each arm, lifted him up, brought him outside, and dangled him over Lithia Springs, which was fortunate for Wes. Lithia Springs is only about 3 feet wide. So he went back in and convinced them that they were just wasting their time, that single sideband was eventually going to take over, and that they might as well get on the bandwagon. And so that was the way it was back then in the 50s. All of these shows were like that. And of course, you know, they had some shows that were in events, hosted in events and dinner venues, kind of like this, except they had maybe hardwood floors because there was dancing, and but chandeliers. If you look at the pictures, that's why I kind of like to have the lights on. It's kind of reminiscent about the way that the single sideband events were held back in the 50s and the early 60s. They were big time things. You know, everybody dressed up in coat and tie to go to them. It was something special. So in any event, you know, moving on a little bit, you know, Central Electronics had the vision to build a lot of different products for the amateur radio market. And in 1962, one of their plans was to have a little novice rig and also CB radio, because Citizens Band was just really starting to become a big thing even back then. You know, because Wes was always looking ahead. He wasn't interested in what we were doing today. He wanted to know what we were going to be doing 3 and 5 years from now. But then suddenly Zenith pulled the switch, and it caught him by surprise. He had no idea they were even thinking about deactivating Central Electronics, but they did it in December of 1961. They made that decision, and it was because color television had taken off, and Zenith was selling close to $295 million worth of color TVs in 1960 and 61. And they looked at the business model for Central Electronics, and it was only doing maybe $2.5 to $3 million. And they decided, well, why do we want to be involved in such a small business when we've got all this opportunity in color television? And that's the reason why they pulled out of the amateur market. But they didn't completely deactivate Central. It moved down to Paris, Illinois. They actually were building a facility there for Central Electronics. It was supposed to move there along with the amateur portion, but they decided not to. And at that facility, they built the power amplifiers and tuners for the Zenith stereo product line in Paris, Illinois. So it continued on, and the reason was Central wasn't a union shop. It didn't have the same union cost and benefit packages that Zenith had to deal with. And so they used it as a way to lower their cost on a product that didn't sell nearly as well, but they needed to have it, which was the stereo component business.
What year did Wes sell to Zenith?
The business was sold to Zenith in 1958. Yeah. So they ran, the latter part of 57. It ran for 4 years when they made the decision to stop. But in that last year, they were working on products such as the novice rig, the CB radio, the 2500L, which was the big 2500 watt input amplifier that was supposed to augment the 600L. Wasn't prototype, but it was breadboarded, and there's a chassis with little modules where they tried different power output tubes. They tried a PL172, a 4CX1000, and then Amperex came out with a tube that was specially designed for single sideband. It wasn't introduced yet, but they were working very closely with Joe Batchelor on the design characteristics of the tube, and I've got it. I actually have that prototype from Amperex, along with the little modules and the chassis that they tested this stuff with. But it didn't happen, of course. They were also looking at a mid-tier design. It was going to be called the 50R and the 50V, going along with the 100V and the 100R receiver idea. And it was going to be a mid-tier product line, which would transceive. And they even had a mobile rig, which was going to have a little digital dial on it instead of an analog. Well, it was analog dial, but it was a digital counter, kind of like on the R390 concept. And we thought all that stuff disappeared. You know, we figured that even Wes thought that once Zenith made the decision to do this and shut down, he always told me that they came in with barrels and just loaded stuff in it, dumped it in, and off it went. And he had actually just tried to not be around for a while that was going on. But the fellow that was actually assigned the project of building the little novice rig was Robert Redfield, and he had started the project. The whole idea of it culminated in a memo from Wes in June of 1961, detailing what he thought a novice rig should have. There was a number of these one-page descriptions of the different products, and I zeroed in on the novice rig because I actually had a photograph of what it was supposed to look like, and it was really attractive. And I was wondering, well, God, you know, if they went that far, what happened to it? Well, it got discovered this year, and quite by accident, I must say. The fellow that discovered it was Bob Redfield's son, Larry. His dad had passed away just a few months before Wes passed away. Wes passed in September. This fellow's dad had died in May. And he had spirited away the Ivanhoe prototype that he had been working on for so long. And somehow he managed to bring it home and kept it all these years, from 1961 all the way up to the time of his passing. And he had gotten it to work, and his son was actually using it as a novice radio back in the early 1960s, the only one. And here it is. It's the Ivanhoe prototype #1, and that's it sitting on the desk right in front of you. Now, this is kind of the thinking that was going into the Ivanhoe product line. It was going to be a 90-watt input set, so it was sellable to general class hams and also novices. CW at AM. Now, this is a thing that really bothered Wes. He hated AM. He spent years trying to get people to get off of AM, but he felt like they had to do it in order to be competitive with Hallicrafters and Heathkit that had AM in their radios. So grudgingly, he put it in, and this caused a big rift between he and Joe Batchelor. I know that because I'd gotten that story from Joe. He really was upset about doing an AM rig. In fact, he said he would not work on the novice rig, which is why Redfield got tasked with it, because normally this would have gone to Joe. It was going to be crystal controlled, but had a VFO input. It would be available as a kit or wired. You know, Wes liked the idea of kits because he felt like it provided a good value for hams, and also for a novice, you'd want a beginning ham to actually experience putting his radio together. Now, the unique thing was that it was styled. The styling wasn't done by Central Electronics at all. It was outsourced to a company called Melvin Bolt and Associates. And this group designed the look of the Zenith televisions and radios from about the mid-50s all the way until Zenith was bought by LG. So they had a very, very long association with Zenith. And so they got this design group to really snazz it up and make it look kind of like a piece of stereo equipment. And it had sequenced grid block King, which they did in a kind of a novel way. They had a number of accessories designed for, or in the planning stages. One was an electronic key. It's going to be simple. It had a single 12AU7 as the keying device. An electronic TR switch was going to be part of it. The side tone, an external matchbox. Wes wanted to have the matching network in the set to match anywhere from a 50 ohm to a 600 ohm circuit antenna system, but you just couldn't package it in a smaller box as they wanted. So they decided to make it external, kind of like a little Johnson matchbox. And it would have its own VFO. And for some reason, they decided they thought they needed to have a DC power supply, which doesn't make any sense because you would need to have a receiver too. But anyway, that was on the drawing board for them to do. Now, the trick about the Ivanhoe, which I thought was really kind of neat, is You know, the other sets, you had to plug the crystals into the back. Or if you had a crystal socket, you only had one in the front. So they decided to make theirs accessible from the front, but have 4 of them in there. And the way they did it was this removable panel in the front. So you'd pull that out, and you'd have access to where the 4 crystals would plug in. And they're on an angle, too, so you didn't have to hurt yourself to pull it out. That's another, you know, back to Wes not wanting to strain. They want to make it easy, so that's how they designed it. The other unique thing is that you see those 4 little vertical bars. You know, your crystals would operate and multiply up on different bands. So you could use those as markers, and they're color-coded. And eventually on the production unit, the crystal switch would have been screened in the different colors to correspond to the 4 vertical bars. That way, by glancing at it, you could tell where your crystal would multiply up on the different bands if you just move those little stripes. So just a little convenience thing, a trick just to get the attention of the buyer, so that, you know, how am I going to position my product to look better and work better than the competitors? You know, he was extremely disillusioned once Zenith did this. He had no idea it was coming. Wes had devoted his entire life, well, since the war, to single sideband and promoting it. And all of a sudden, it was just gone. And that was the reason he retreated from HF radio. And he told me that when I had met him and became friends, you know, because I kept asking, why don't we put up an antenna and get you on? I said, no, I don't want to do that. And it was because of that. He felt embarrassed because the company and had just disappeared, and he didn't want to keep answering those same questions over and over again. But you know, when we started to get together and got him on the air again, and he would start to go to the Ham Fest again and interact with people, and could see how much of a following from the collector community there was. He had no idea that people wanted to use and restore and operate his equipment, and that it made that much sense. So, you know, because of that, it kind of got him back out, and he was interested in the collect. He was just thrilled whenever these people would come up to him and talk to him about it. And he had a great time whenever we'd have these vintage field day events, because they would get him back on the air again, and he just enjoyed that every time. So, you know, and thank you for your interest in Central Electronics. It made a big impact on Wes in his final golden years. And I think it also made an impact on you too. Thanks. Now, I'll set the Ivanhoe up while George is doing his presentation, and you can experiment with it. We'll have it set up with a scope so you can look at the waveform and output and all that stuff, and flip it over and examine it. I've also brought with me all the surviving documentation that came with the Ivanhoe, and in itself is very interesting to see the amount of work and effort that goes into building a product. It's not a snap of the fingers. It takes a lot of work to make a product where it's reproducible. Anybody can build this one thing, but it's a big deal to build something, to make it so that you can reproduce it in hundreds or thousands of units and have uniformity. And that's the real trick to manufacturing. And he was an expert at it. Thank you.